For number corner today, we're going to be doing a problem string. So you need your number corner book. We're going to open to the number or problem string workspace at the middle-ish back half of your number corner book. So that is on page A6. Once you have your number corner book open to page A6, you're going to add the date. You might also want to find in your folder I sent home with you, you had some clock fraction pieces or papers that had blank clock faces on. So if you decide that, hey, clock faces help me do these problem strings, I can grab those and use those. Remember, you also have that option of opening the Bridges math apps and finding the clock faces that way. All right, let's get started. The first problem that you're going to be writing down is what is 1/2 minus 1/3? So if I have my Bridges book open to my workspace, I'm going to write down the equation. Oops, let me get my pen out. 1/2 minus 1/3. Now I'm going to go ahead and show that on my clock faces. You do the same. All right, so I went ahead and I showed half on my clock and I showed 1/3 on my clock. But now I need to subtract. So I have to kind of figure out how am I going to do that? And I know that I am subtracting this 1/3. And I notice that if I look at it, I can say that, hey, there's 1, 2, 3, 4 sections of my 12 sections, right? And if I look here, I can say, well, hey, 1, 2, 3, 4 sections, that would be what comes off. So what am I left with? 1, 2 sections. So I can say that I am left with 2. How many are in a clock altogether? 12s. That's right. Remember, when I think about it, I want to rewrite it with an equivalent fraction. So instead of thinking of this as 1/2, I looked at it as 6/12. Instead of looking at this as 1/3, I looked at it as 4/12, and that's how I got my answer of 2/12. Could I have looked at it differently? Yeah, sure. I could have instead saw that, hey, there are 3/6 here. This is 2/6. I could have also said I have 3/6 minus 2/6 equals 1/6, right? Because I see that, hey, I have one of those pieces left over. So I could say 2/12 or 1/6. All right, moving on to the next problem. What is 1/3 minus 1/4? Remember that I have to think about, is clocks going to be a better model or is money going to be a better model? And just like up here, I had thirds, so clocks are a better model. I have a third down here, so again, clocks are going to be that better model. So using your clock pieces or draw them out or using the app, show 1/3 minus 1/4. All right, so from above, I saw that, hey, that was 1/3, so this is I'm going to do that same amount, 1/3 here, minus 1/4. I showed that in green. So how would I go about solving this? What answer did you get? Again, I see that I don't have the same size pieces, so I want to rewrite it as an equivalent fraction. So instead of thinking this as 1/3, so hopefully we already wrote down 1/3 minus 1/4 as our problem. That's the same as, well, let's count 1, 2, 3, 4 12s. Oh yeah, that makes sense. We said 4 12s up top here. 4 12s minus, and this is 1, 2, 3 12s. Then I get 1/12 as my answer. Because if I come back here and take off my 1, 2, 3, 1, 2, 3 12s, cross those off, I'm left with that 1/12. So if you didn't get that answer, think about how did Mrs. Ellison explain it and what might you do different next time. All right, moving on to the next problem. What is 1/4 minus 1/6? So just like before, we're going to write that down. 1/4 minus 1/6. 6. 6 times what is 100? Ooh, it's not a whole number. So money isn't going to be an easy model to work with. If I had 60 minutes and I break them into 6 groups, 6 times what equals 60? Oh, I know that one. So clocks are going to be the way I'm going to go. So how would you represent 1/4 minus 1/6 on your clocks? Go ahead and fill those in. Right, hopefully yours looked somewhat like this. I broke it into 4 pieces, shaded in 1, broke it into 6 pieces, shaded in 1. Hey, 6 times 10 equals 60, so here is my 10-minute section. All right, how would you go about solving this? How would you subtract 1/4 minus 1/6? All right, hopefully you came up with your answer. If I look at this, again, I don't have a common denominator. They're not the same on the bottom. So I want to think about how do I rewrite this so that they do have the same number on the bottom. Again, I'm looking at those pieces, right? Here is 1, 2, 3. This is 1, 2. So I can rewrite that as 3/12 minus 2/12 equals, yeah, hopefully you got 1/12. Again, I can see that with my model. If I look at this and say, hey, I need to fill in shade in 1, 2 sections, right? I'm taking that part off and I'm left with this one section, 1/12. All right, next problem, 1/6 minus 1/12. Hey, I know that 6ths and 12s, they work really good on a clock. So I know that I'm going to stick with my clock. I'm going to go ahead and write down my problem, 1/6 minus 1/12. I'm going to use my clock model or my app to try and solve that. So go ahead and give it a shot. All right, so hopefully you broke your first clock piece into 6 pieces and shaded in 1, and then broke your second clock up into 12 pieces and shaded in 1. So now I need to figure out how am I going to subtract 1/6 minus 1/12. So take a second and come up with your answer. So if I subtracted off this piece of 1/12, hey, I see that this is 1, 2, this is 1. All right, so hey, I'm going to come back here and take off this 1/12. And what am I left with? Hey, I'm left with 1/12. So I want to rewrite this with a common denominator. 1/6 is the same as 2/12 minus 1/12, already a 12, equals that 1/12. Nice. All right, and then our next problem, 2/3 minus 1/2. Again, 2/3, thirds works much better with clocks. So figuring out how am I going to show 2/3 minus 1/2 on my clocks, I'm going to write out that problem, 2/3 minus 1/2. I see that I don't have the same size pieces. One is thirds, one is half. So I'm going to rewrite that with a common denominator. So what would that look like on your clock model? What would your common denominator equation look like? All right, so hopefully you broke up your clock and said, hey, here is thirds, 1/3, 2/3. Here is a half. Oh, I needed to rewrite that with a common denominator. So if I look at how many pieces, how many sections of that clock of those 12ths did I fill in? Well, I see that I have 8/12. And then that is 6/12. So 8/12 minus 6/12. So how would you go about solving that? Tell me what your answer is. All right, if I did this and I took off that half, I could see that, hey, here is that half of the clock. I'm crossing this part off. What am I left with? Oh, I'm left with 1, 2 sections. So I can finish my equation of 8/12 minus 6/12 equals 2/12. Now remember up above that 2/12 was also the same as 1/6. So I can go ahead and say or 1/6. And that makes sense because if I broke this into 6 pieces or 6, right, I would have 1, 2, 3, 4 of them. Here I would have 1, 2, 3 of them. So that works as well. Our final problem here, you're going to write down 5/6 minus 1/12. Again, we're working 6 and 12, so definitely works better on that clock face. So go ahead, write down the problem, 5/6 minus 1/12. and then get your clock fractions out. How would you go about solving that? Remember to rewrite it using equivalent fractions with common denominators. All right, so when I get my clock fractions written out, I see that I have 5 out of 6 filled in here, 1 out of 12 filled in here. If I go and remove one of my 12s, right, so that would be this section right here, this 12th of the clock. How many am I left with? Well, I see that I had 2, 4, 6, 8, and one more is 9. So that I could say my answer is 9/12. If I look at the clock, though, I notice something else about the amount that's left over. I could say that I also have, hopefully you saw that, 3/4. So remember, again, finding that common denominator, finding those equivalent fractions, rewriting my equation to show that before I solve, because my pieces need to be the same size before I add or subtract. All right. Thank you for participating in Number Corner, and make sure you submit your assignment.